When it comes to computer networking, so we are going to send information from one device to another device, right? On that time, here you can see we have this device, right? So we have one PC here, you can call this a node, then after router, another router, then another device, another node. So we have two different routers, that means you can connect, we are connecting between two different network, right? Two or more different network. So this device in one different network, this device in one different network. For example, think this as a device 1. Device 1 going to send one information to device 2. On that time, when he send this information, it will go through these layers, right? We have application layer, presentation layer, session layer, transport layer, network layer, physical layer. We have this PDU, that means protocol data unit. So when you send your data, when that data is going through all of these layers, right? So when that data is going to move through these layers, each of these layers will add a header file to this data, right? Finally you will have a IP header and your data. Then after you can transfer this data. After that, in the receiver end, again there will be a data header removing process. So again it will go through the physical layer, data link layer, network layer, transport, session, presentation, final application layer, and it will show the data packet. So when it comes to first three layers, application, presentation, session, we are calling a data, right? But after it came to transport layer, it will become a segment. Then after it will become a packet. Then after frames, and finally it will send as a bit through our medium, right? So we have basically two models, TCP/IP and OSI model. So we are going to discuss OSI model in this series. So in the next video, I will explain the TCP/IP model. So this OSI model is developed by the International Organization for Standardization, that means ISO. So this is standard, international standard setting body, right? So this was designed as a reference model for describing the function of a communication system. So we have this definition. OSI model is a framework used to understand and describe the function of a networking system. It divides communication process into 7 distinct layers, each with specific responsibilities. These layers enable to implement some functionality into a networking device, enabling easy interoperability with devices from other vendors. So basically they introduced this model concept because there are multiple vendors, multiple companies, right? So they have multiple companies, but when you take a switch from one company and again you are taking another switch from another company, so you are going to use both of these switch in your company network. On that time you should have a common standard, right? As a common standard, they have developed this OSI model. So we have 7 layers. To remember these 7 layers, you can use these letters, right? Here you can see we have please do not throw sausage piece away. Please mean physical layer, do data link layer, N network layer, 3 transport layer is the session layer, then our presentation layer and application layer. You can remember these layers using this sentence, right? Okay, so we will discuss these layers one by one. We have basically physical layer. It will deal with what? Physical transmission of our data, right? It is going to deal with physical transmission of our data. It could be a wired medium or wireless medium. And also it will handle issues like signal encoding, bit rate, these kind of issues. For the transmission medium, you can use copper cable or fiber optic cable or wireless medium. Then after we have data link layer. So basically this is responsible for reliable data transfer between two nodes on a network. Encapsulate that packet in a frame. A frame contains a header and a trailer that enable device to communicate. So when you take a data frame, we have a header and trailer, right? So we are going to discuss this thing in the upcoming videos. A header contains source and destination MAC address. MAC address means physical address of your device, so which is allocated to your network card, NIC or network interface card. Then after IP address means, or source address or IP address means a logical address given by us or DHCP server. A trailer contains a frame check sequence. So to check is there any errors or not, we are adding a frame check sequence which detect transmission errors. So we are doing CRC check, that means cyclic redundancy check, to identify these errors. So basically data link layer will handle error detection and correction, also flow control and framing, right? And also it is responsible for reliable data transfer between node in our network, node in our end device. After that we have network layer. So this is mainly concerning about the delivery of our data packet from source device to destination device on our network. And also network layer will do the routing, addressing and our congestion control tasks. So define device addressing, routing and path determination. Device addressing is used to identify host on a network, that means IP address, responsible for routing packet through network. So we are going to discuss about transport layer. When it comes to transport layer, basically it is concerned about the providing reliable end-to-end communication between our application, and also it will handle flow control, error detection and error correction, and also multiplexing. This kind of thing will be handled by transport layer. You can see we have this definition: provide end-to-end communication between application, right? I'm going to take highlight. It will provide end-to-end communication between our application. Segment big chunk of data received from the upper layer protocol. That means when you take a two device, for the example I am taking two device, you are connecting these two devices using a medium. There is a limitation for this medium. It could be a 1 Mbps cable, 100 Mbps cable, or 10 Gbps fiber optic cable. Based on the maximum transmission unit of this cable, you need to divide your data pack into smaller segment. So this smaller segment we are calling a segment, right? We have a big chunk, we are dividing into smaller part. Then now we can call this segment. So we will discuss segmentation in the upcoming videos. Then now it will establish and terminate connection between computers. So when you try to send information, it will make a connection between your source and destination device, used for flow control and data recovery. After that we have session layer. So basically this will establish, manage and terminate communication session between our application, and also this can handle synchronization, checkpointing and dialog control. So define data format. So this is one task. Compression and encryption are defined at this layer, and also it will establish, manage and terminate session between application, session layer. So we have discussed 5 layers. Now we have presentation layer. So basically this will translate data into a format suitable for our application. So we are getting a bit, so bit by bit it will convert this data into the particular format. It could be a HTTP web information or video file or zip file or PDF, this kind of information, right? After that finally we have application layer. This layer is closest to the user. So as the user we are interacting with this layer. So not as a network admin, as a user we are interacting with this application layer. So provide services to end users, that means for us. And also it will provide the services like again file transfer, email, web browsing, these services. It enables network application to communicate with other network application. By using this layer we can communicate with other network application, and also it will provide network services to user application, right? So when you take this user layer, each layer built upon the service of the layer below. Data is encapsulated as it moves down the layer, adding its own header information. As I told, when it moves through these layers, it will add header information in each and every layer. After that, it will send to destination device again. Then it will remove these headers when it passed these layers until it came to the application layer.